In the rainforest, the ground is never truly still. Leaves shift, branches fall, gaps open. For most animals, these obstacles are barriers. For ants, they're just engineering problems, because some ants don't just cross gaps. They become the bridge. Here are 6 facts about one of the most astonishing behaviors in the insect world. 1. Army ants build bridges with their own bodies. Certain species, like the army ant, can link their bodies together to form living structures. When the colony encounters a gap between branches over a crack in the ground, across uneven terrain, worker ants grab onto one another using their legs and jaws. They lock together, layer by layer, until a stable bridge forms. Other ants then march across their bodies as if walking over solid ground. No blueprint, no foreman, just instinct and coordination. 2. The bridge is dynamic, not static. This isn't a frozen structure. Living ant bridges are constantly adjusting. If traffic increases, more ants join the structure to widen it. If fewer ants are needed, some detach and return to foraging. It's a flexible, self-correcting system. Scientists have observed that ants will reposition themselves to shorten or strengthen the bridge depending on the angle and flow of movement. It's not random. It's responsive. The structure adapts in real time. 3. Individual ants sacrifice mobility for the colony. The ants forming the bridge are temporarily giving up their ability to move freely. They become infrastructure. They stop foraging. They stop exploring. They simply hold on, sometimes for hours. Why? Because in ant colonies, survival isn't about the individual. It's about the superorganism. An ant colony functions like a single living entity, with thousands of tiny parts working toward one shared goal. The bridge isn't self-sacrifice in a human emotional sense. It's biology optimized for collective survival. The colony calculates efficiency. Without a brain in charge, no single ant directs the operation. There's no central command. Yet the colony appears to decide the most efficient bridge length and position. How? Through simple rules. Each ant responds to local cues. The pull of other ants, the tension in the structure, the density of traffic crossing. From these basic interactions, complex behavior emerges. This phenomenon is called emergent intelligence, where large-scale coordination arises from small, simple actions. It's the same principle that explains flocking birds, schooling fish, and even some aspects of human networks. Tiny minds, massive outcomes. 5. Ant bridges can support hundreds of ants at once. Despite being made entirely of living bodies, these bridges are surprisingly strong. An individual ant can carry many times its own body weight. When combined in layers, the structure distributes force efficiently. The ants grip each other using claws and adhesive pads. The result? A flexible but stable crossing that can support constant movement. It may look fragile, but it's biomechanically impressive. Nature rarely wastes design. 6. This behavior is millions of years old. Army ants have existed for tens of millions of years. This bridge-building strategy isn't new. It's an ancient survival tool refined by evolution. Rainforests are chaotic environments. Storms break branches. Floods reshape terrain. The ability to instantly form living structures allows these ants to move efficiently through constantly changing landscapes. Instead of building permanent bridges, they become temporary ones. When the obstacle is gone, so is the structure. No waste. No permanent materials, just living architecture. From a distance, it's easy to overlook ants. They're small, common, easy to ignore. But up close, they reveal something extraordinary. A colony acting as one organism. Thousands of individuals functioning like cells in a body. Forming bridges, roads, rafts, even floating islands during floods. They don't need leaders shouting commands. They don't need blueprints. They rely on simple rules repeated thousands of times. And from that simplicity, complexity emerges. When you see a line of ants crossing the forest floor, you're not just watching insects. You're watching a decentralized civilization. An ancient system perfected over millions of years. Tiny creatures solving massive problems, not with tools, not with machines, but with each other. Sometimes the most incredible engineering on Earth is only a few millimeters tall.